Welcome to today's explainer. If you take a look at your calendar, most days probably just seem, well, completely ordinary. Just a random collection of mundane appointments and errands. But every once in a while, history hides this massive coincidence on a single square of that calendar. Today, we're looking at July 16th. And as you're going to see, this is arguably one of the absolute greatest dates in mathematical history. We're about to dive into exactly why. Because on this exact calendar date, across totally different centuries and different countries, brilliant minds were born who fundamentally changed the very fabric of the world we live in right now. I mean, we're talking thinkers from the 1700s right up to the 20th century, tackling completely distinct challenges. Yet, they all share this one incredible birthday. So, let's jump into this timeline and actually meet these pioneers one by one. Let's start with a bit of a mystery. Have you ever actually wondered how a modern spacecraft like NASA's Dawn mission manages to navigate deep space? I mean, think about it. We're talking about an object traveling billions of miles, moving at tens of thousands of miles per hour, and somehow perfectly threading the needle through the vast, empty darkness of our solar system just to orbit a tiny, distant asteroid. How on Earth, or, well, off Earth, does it know where to go? Well, the answer to that hyper-modern engineering marvel actually goes all the way back to July 16, 1746. It points us to a really fascinating astronomer named Giuseppe Piazzi. And just think about his era for a second, right? He was doing his work way, way before the invention of computers, digital software, or even modern high-powered telescopes. Working with the pretty limited tech of his time, what Piazzi achieved was honestly staggering. He meticulously observed the sky night after grueling night, tracking exact stellar coordinates completely by hand. And through this intense dedication, he eventually mapped over 6,700 stars with unprecedented accuracy. Actually, it was this rigorous mathematical discipline that led him to discover the dwarf planet Ceres in 1801. That wasn't just some lucky accident. It was the direct result of building the most accurate mathematical grid of the sky anyone had ever attempted. So the crucial takeaway here is this. Every mission to the stars begins with a mathematical map. The exact stellar coordinates and mapping techniques that Piazzi pioneered laid the literal groundwork for the navigation codes running inside modern NASA computers today. Without his 18th century dedication, our 21st century rockets, they'd be flying completely blind. Okay, so we're still on July 16th, but now we're going to jump forward in time to the year 1801. Because while Piazzi was busy discovering Ceres and mapping the physical sky, another mind was just being born, one who would map a realm completely invisible to human eyes. Think about this for a second. How is it even possible for us to conceptualize higher dimensions of space when our brains and our bodies are totally trapped in the three-dimensional world we see every single day? It's kind of like asking a 2D stick figure drawn on a flat piece of paper to somehow imagine the volume of a 3D cube. It just feels impossible, right? But the answer to this mind-bending geometric puzzle goes back again to July 16, 1801, with the birth of a mathematician named Julius Plücker. Plücker was the kind of thinker who absolutely refused to be constrained by what his eyes could physically see in the tangible world around him. He completely shifted our perspective on reality. Up until his work, geometry was always based on points in space. But Plücker redefined it all by using straight lines, not points, as his fundamental building blocks. And here is why that's so genius. It takes 4 numbers to define a line in 3D space. So by shifting that foundational unit from a point to a line, he naturally generated a 4-dimensional mathematical structure. He essentially created the very first mathematical model of 4D space, giving us the toolkit to calculate and prove the existence of higher dimensions. And this brilliantly illustrates our next big takeaway. The universe is built on dimensions we can calculate, even if we can't see them. This matters immensely today, because modern theoretical physics, quantum mechanics, string theory, they all rely entirely on the foundational 4D math that Plücker dared to imagine over 2 centuries ago. So, same date, just over a century later. We're moving from the abstract geometry of the universe to the literal building blocks of biological life. Here comes 1902. We have another incredible real-life mystery on our hands here. Just picture a messy, tangled shoelace or knotted piece of string. What could the shape of a simple physical knot possibly have to do with the microscopic, biological instructions hidden inside your very own body? How do these wildly different scales of reality even connect? The answer, once again, goes back to July 16th, 1902, and a brilliant mathematician named Gheorghe Călugăreanu. Now, when Călugăreanu first started his work, it seemed incredibly abstract and highly niche. It was almost like studying the math of tangled headphones just for the sake of it. But he dedicated his life to studying the invariant properties of 3D knots in differential topology. Now, an invariant is really just a property of a knot that absolutely does not change no matter how much you pull, squish, or stretch it. And as it turns out, Călugăreanu's formulas were exactly what molecular biologists ended up needing. See, every single human cell contains about 2 meters of DNA, and all of that has to continuously fold, coil, and twist to fit inside a microscopic space. His pure geometry literally became the key to understanding how our DNA knots and unknots itself just to keep us alive. It is absolutely fascinating when you realize the deepest secrets of life itself are tied in mathematical knots. Seriously, every single time your cells divide to heal a cut or grow new tissue, your biological structure is actively relying on the very knot mathematics that he pioneered. One date, so many stories. Let's keep going, jumping just a single year forward on our calendar to 1903. And just to anchor this in history for you, 1903 is the very same year the Wright brothers successfully took flight. And wouldn't you know it, on July 16th, a mind was born who would eventually help steer flying machines just like theirs. Ask yourself this. When you use automated conveniences every single day, like setting the thermostat in your hallway, turning on cruise control in your car, or watching a drone stabilize itself in the wind, how did those machines actually think for themselves to make those instant corrections? Well, the brains behind our modern smart devices lead us straight to July 16th, 1903, and an absolutely incredible engineer named Irmgard Flügge-Lotz. Not only was her mind brilliant, but she was a pioneering female engineer making massive waves in a heavily male-dominated aerospace field during the early 20th century. She completely pioneered the mathematics of discontinuous automatic control systems. Okay, let's break that jargon down. Think about your home thermostat again. When it gets too cold, it doesn't just gently and continuously push out tiny puffs of heat, right? No, it clicks forcefully and fully on. And then once the room is warm, it clicks fully off. This is what's known as bang-bang control. Flügge-Lotz figured out the exact highly complex math required to use these simple, abrupt on and off correcting forces to reliably stabilize highly advanced machines, like airplanes flying through turbulent skies. Her groundbreaking mathematical frameworks paved the way for automated engineering around the globe, basically proving that every smart device you own is secretly powered by automatic control math. Without her insights, the automated comforts we take for granted every day simply wouldn't exist. When we pull back and look at this timeline from 1746 to 1903, it's just truly amazing. Every person we met today helped build the foundation of our modern world. From Piazzi charting space exploration, to Plücker imagining 4D physics, to Călugăreanu unlocking DNA biology, and finally Flügge-Lotz giving us smart tech. That is 4 completely disparate challenges, united by one single date on the calendar. And what actually connected them all? Well, they all asked the exact same question. What is the pattern hiding inside the chaos? Next time you look at the calendar hanging on your wall, remember that today's date might just be the birthday of the person who's going to solve tomorrow's greatest mystery. Thanks for joining me on this explainer, and hey, keep looking for the patterns in your own world.